Everyone knows light is fast. Everyone's heard that nothing can go faster. Everyone thinks they understand what the speed of light means. And everyone is wrong about what they're actually talking about. Because the biggest misconception about light speed isn't that it's a speed limit. It's that it has anything to do with light at all. And once you understand what's really going on, you realize you've been asking the wrong questions your entire life about how reality works. The misconception starts with the name itself. We call it the speed of light. Like light is special. Like photons have some unique property that makes them the fastest thing. Like light won the cosmic race and got its name on the trophy. But that's backwards. That's completely backwards. Light doesn't travel at the speed of light because light is special. Light travels at that speed because light has zero mass. And anything with zero mass has to travel at that speed. It has no choice. It's not trying to go fast, it's not racing anything. It just exists at that velocity because that's what massless particles do. But here's the thing that'll twist your brain. The speed itself has nothing to do with light. Light is just the messenger we happen to notice first. The speed of light is actually the speed of causality, the maximum rate at which cause and effect can propagate through the universe, the speed at which now becomes then, the update rate of reality itself, and we just named it after light because that's what we measured it with. Like naming gravity the Apple force, because that's what Newton was looking at when he figured it out. Here's what I mean. Imagine you're holding a perfectly rigid stick, like impossibly rigid, no flex at all, stronger than diamond, stronger than neutron star material, perfect rigidity, and this stick is 1 light year long. Now you push one end. How long does it take for the other end to move? Common sense says instantly, right? You push this end, and the other end moves at the same time because it's rigid, it's all connected, it's one object, there's no gap, no delay, just instant transmission. Wrong, completely wrong. The other end doesn't move for at least a year, minimum, because the push has to propagate through the stick at the speed of information transfer, which is the speed of light. And here's why this matters. There's no such thing as perfectly rigid. Rigidity is an illusion. It's just atoms pushing on other atoms through electromagnetic forces. Electrons repelling electrons, and electromagnetic forces propagate at light speed. They can't go faster. So when you push one end of the stick, that push travels through the material as a compression wave, atom pushing atom down the entire length. And that wave moves at the speed of sound in the material, which is way slower than light speed. But even in a theoretical perfect material with instant atomic response, the information still can't propagate faster than light, because information itself is limited by the speed of causality, which means you can't use a long stick to send instant messages to aliens, light year away. You can't cheat causality with a stick. You can't outwit the universe with engineering. The universe won't let you. The structure of space-time itself prevents it. Or think about gravity. The sun is pulling on Earth right now, keeping us in orbit, but the sun is 8 light minutes away. So which sun is pulling on us? The sun as it is right now, or the sun as it was 8 minutes ago? And the answer that should disturb you is we're being pulled by the sun as it was 8 minutes ago, because gravitational influence propagates at the speed of light. If the sun vanished right now, we wouldn't know for 8 minutes. We'd keep orbiting an empty point in space for 8 minutes until the information, the sun is gone, reached us traveling at light speed. And only then would Earth go flying off in a straight line. And before you ask, yes, this has been tested. Yes, gravitational waves travel at the speed of light. We measured it in 2017 when we detected both gravitational waves and light from the same neutron star collision. They arrived at the same time after traveling for 130 million years. Same speed, because it's not the speed of light, it's the speed of information, the speed of causality, the speed at which reality updates. Now here's where it gets weird. And by weird I mean Feynman-level mind-bending. The speed of light isn't actually a speed. It's a conversion factor. It's the exchange rate between space and time. It's what you get when you ask, how much space equals how much time? And the universe says, 299,792,458 meters per second. That's the conversion rate. That's how space and time relate to each other. Which sounds like word salad until you realize that space and time aren't separate things. They're two aspects of the same thing, space-time. And they're interchangeable. You can trade motion through space for motion through time, and the speed of light is the exchange rate. It's not a speed limit on objects. It's a structural property of the universe itself. It's how space and time are woven together. Think about it this way. Why is the speed of light exactly 299,192,458 meters per second, and not some other number? And the answer is, because humans defined the meter, we made up that unit. We could have defined it differently and gotten a different number. But the actual physical thing that number represents, that's fixed. That's fundamental. That's part of the structure of space-time. In fact, we've now defined the meter in terms of the speed of light instead of the other way around. 1 meter is defined as the distance light travels in 1,299,792,458 of a second. Because the speed of light is more fundamental than our measuring sticks. The speed of light is the measuring stick. It's the ruler the universe uses to relate space to time. So when you hear, nothing can go faster than light, what that really means is nothing can go faster than causality. Nothing can outrun cause and effect. Nothing can move so fast that effects happen before causes. Because that would be moving backwards in time, and the universe is structured in a way that prevents that. Not because of some law, not because some cosmic referee will blow a whistle, but because the geometry of space-time itself makes it incoherent, makes it meaningless. Like asking what's north of the North Pole or what happened before time began, the question sounds like it makes sense, but it doesn't. It's grammatically correct nonsense. And here's the dark humor in all this. We've been arguing about faster-than-light travel for decades, building theories about warp drives and wormholes, writing science fiction about breaking the light barrier, spending billions on research into exotic matter and negative energy, when the whole time we've been confused about what we're even trying to break. We're not trying to go faster than light. We're trying to go faster than the speed of information, faster than causality itself, faster than reality updates. Which is like trying to watch a movie faster than the projector can display frames. You're not fighting the movie, you're fighting the projector, and the projector is the universe, and the frame rate is fixed. It's the speed of light, and no amount of clever engineering changes the frame rate of reality. But here's where it gets interesting, where the misconception actually matters for practical reasons. If you understand that the speed of light isn't about light, if you understand it's about the structure of space-time, then you start asking different questions. You stop asking, how do we make our rockets faster? And start asking, how do we manipulate space-time itself? You stop thinking about propulsion and start thinking about geometry. And that's where concepts like warp drives actually come from, not from making things go fast, but from bending space around you, creating a bubble where space contracts in front and expands behind. And you're not moving through space faster than light. You're moving space itself. You're surfing a wave of space-time geometry. And the math says this is theoretically possible. It doesn't violate causality. It doesn't let you travel backwards in time. It just requires exotic forms of matter. Energy that we don't know how to create yet. But the point is, you have to understand what the speed of light really is before you can even conceive of ways around it. You have to know you're fighting geometry, not velocity. Same with wormholes, shortcuts through space-time. You're not going faster than light. You're taking a different path through the geometry, like folding a piece of paper so two distant points touch. You're not breaking the speed limit. You're just taking a shortcut through higher dimensions. And again, the math allows this in principle. Einstein's equations permit it under certain conditions. It just requires conditions we can't create. But the fact that we can even think about this, even conceive of these possibilities, comes from understanding that space-time is geometry, not just empty space with time flowing separately. Comes from taking seriously the idea that the speed of light is a structural constant, not a speed limit on objects. The real misconception isn't that light speed is fast. It is fast, insanely fast, fast enough to circle Earth 7.5 times in 1 second. The misconception is thinking it's a speed at all, thinking it's about velocity, about going fast, when really it's about structure, about how space and time fit together, about the fundamental architecture of existence. And we just happened to discover this structure by measuring light, so we named it after light, but we could have discovered it 100 other ways. We could have measured gravitational waves first, or studied particle physics, or worked out the mathematics of space-time, and we would have found the exact same number, the same fundamental constant, and we might have called it something else, the speed of causality or the space-time conversion factor or the universal update rate. But it would be the same thing. The same fundamental feature of reality that light happens to travel at, because light has zero mass. Feynman understood this deeply. He spent years trying to get people to stop thinking about the speed of light as a speed limit, and start thinking about it as a structural constant. He'd say things like, light doesn't know it's going at the speed of light. Light doesn't have a speedometer. Light just exists and moves. And that's the rate it moves, because that's what the geometry of space-time allows. And what he meant was that we've got the causality backwards. We think light goes at light speed, because light is special. When really light goes at that speed because space-time has that structure, and anything massless has to move at that speed. And that speed is fundamental. It's built into the fabric of reality. It's the conversion factor between space and time. It's not a property of light, it's a property of existence. He'd give lectures where he'd talk about how the universe doesn't care what we call things, doesn't care about our names and labels. The universe just is. It has properties and structures, and we discover them and name them, but the names don't matter. What matters is understanding the actual relationships, the actual geometry, the actual way things work. And the speed of light is a perfect example of this. We named it wrong. We gave it a name that implies it's about light when it's really about space-time. But the universe doesn't care about our naming mistake. The universe keeps working the same way regardless. Space-time keeps having the same structure. The conversion factor between space and time keeps being the same number. And if we want to understand reality, we have to get past the names and labels and see the actual structure underneath. And this is what made Feynman such a good teacher. He didn't just tell you the equations. He made you understand what the equations meant, what they were telling you about reality. He'd break down your intuitions and rebuild them from scratch. He'd take concepts that seemed obvious, like things that are moving fast go fast, and show you why that's not even wrong. It's just confused. It's asking the wrong question. It's like asking why rocks want to fall down. Rocks don't want anything. They're following the geometry of space-time curved by mass. Down is just the direction that geometry points. And similarly, fast isn't a thing light is trying to do. It's a consequence of light having zero mass in a space-time with a particular conversion factor between space and time. And this has real consequences, practical consequences, not just philosophical. GPS satellites have to account for the fact that time runs differently for them than for us, because they're moving and they're in a different gravitational field. And if we didn't correct for this using Einstein's equations, GPS would be wrong by miles, completely useless. Particle accelerators can push protons to 99.9999991% the speed of light, 7 nines. But no matter how much energy we pump in, we can't get to a 100%. We can get arbitrarily close, but never quite there. And the reason isn't that our accelerators aren't powerful enough. It's that we're not fighting a speed limit. We're fighting the structure of space-time itself. We're trying to trade motion through time for motion through space, and we're running out of time. Motion to trade. We're approaching zero motion through time, which corresponds to maximum motion through space. And you can't have negative time motion. Zero is the floor. And that floor is the speed of light. Cosmic rays hit Earth's atmosphere and create particles called muons about 15 kilometers up, and these muons should decay in about 2 microseconds, which means they should only travel about 600 meters before decaying, which means they should never reach the ground. But they do reach the ground. We detect them all the time. About 1 per square centimeter per minute at sea level. So what's happening? Are they living longer? Are they traveling faster? And the answer is both, depending on your perspective. From our frame, the muons are living longer because time is passing more slowly for them because they're moving at 98% light speed. From their frame, they're only living 2 microseconds. But the distance to Earth is contracted. Space itself is compressed in the direction of their motion. Either way you calculate it, you get the same result. They reach the ground. And this isn't theory. This is measured. This is confirmed. This is cosmic rays proving relativity every single day. Proving that space-time really does bend and flex to keep the speed of light constant for everyone. And you can test this yourself without a particle accelerator or a telescope. Just 2 atomic clocks and an airplane. Take one clock, leave it on the ground, take the other one on a commercial flight around the world. When you land and compare them, the flying clock will have lost a few nanoseconds. Not because it's broken, not because of vibration or temperature or any mechanical issue, but because less time literally passed for it, because it was moving. This was done in 1971 by Hafele and Keating. They flew atomic clocks on commercial airlines and measured the time difference. And it matched Einstein's predictions exactly, to the nanosecond, which means every time you fly somewhere you're aging microscopically slower than people on the ground. You're experiencing time dilation. You're proving relativity with your body. You just can't notice it, because the effect is so tiny at airplane speeds. But it's there. It's real. It's happening. Your phone's GPS is doing relativistic corrections right now. This second, the satellites are moving at about 14,000 kilometers per hour, which makes their clocks run slow by about 7 microseconds per day, but they're also 20,000 kilometers up in a weaker gravitational field, which makes their clocks run fast by about 45 microseconds per day. Net effect is their clocks run about 38 microseconds per day faster than clocks on the ground. And if we didn't correct for that, your GPS would drift by about 11 kilometers per day. After a week, you'd be 80 kilometers off. Completely useless. So every GPS satellite is running a computer that's constantly adjusting its clock, based on relativistic calculations. It's taking the speed of light seriously, not as a speed but as a conversion factor between space and time. It's treating space-time as a unified thing with geometry. And it works. It works perfectly. Billions of people use it every day without thinking about it, without knowing depending on Einstein being right about the structure of reality. So here's what you need to understand. What Feynman wanted everyone to understand. When you hear about the speed of light, stop thinking about light. Light is just the messenger. Light is just what we happen to measure first. The thing that's actually fundamental is the structure of space-time. The fact that space and time are woven together with a specific conversion factor. And that conversion factor is what we call the speed of light. But it's really the speed of everything. The speed at which reality propagates, the maximum rate of cause and effect, the universal update frequency. And that's not a speed limit on objects. That's a property of the universe itself. That's how existence works at the most fundamental level. Think about what this means. Really think about it. There's a maximum rate at which anything can happen, a fastest possible speed for any change, any influence, any effect. And that maximum is built into the geometry of space-time itself. It's not negotiable. It's not something you can engineer around. It's part of the definition of what space and time are. And this tells us something profound about the nature of reality. It tells us that space and time aren't just backgrounds where events happen. They're dynamic things with structure and properties. They're parts of a unified fabric that has rules and geometry. And one of those rules is this conversion factor, this maximum rate, this speed we call the speed of light. And the really mind-bending part, the part that should keep you up at night, is that this means the universe has a frame rate. Reality updates at a certain maximum speed. Information propagates at a finite rate. Cause and effect take time to spread. There's a delay built into the fabric of everything, which means in some sense the universe is computing itself, processing information, updating its state. And there's a maximum clock speed for that computation, and that clock speed is the speed of light, or rather the speed of causality, the speed at which the next moment emerges from this moment, the speed at which now becomes then. And this raises questions that physics can't answer yet. Why does space-time have this particular conversion factor? Why is the speed of light this specific number and not some other number? Why does space trade for time at this exchange rate? And we don't know. We can measure it, we can use it, we can predict things with it, but we can't explain why it has the value it does. That's just what we measure, that's just what the universe is. And maybe someday we'll find a deeper theory that explains it, or maybe it's just a brute fact. A number that had to be something and happens to be this. But either way, it's there, it's real, it's fundamental. And it's not about light. It never was. And this is what separates pop science from deep science. Pop science tells you light is fast and nothing can go faster. Deep science tells you that speed isn't speed. It's geometry. It's the shape of space-time. It's the exchange rate between dimensions. It's the conversion factor that makes space and time two aspects of the same thing. And once you see it that way, once you really understand it, you can't unsee it. You can't go back to thinking about space and time as separate. You can't go back to thinking the speed of light is about light. You realize the universe is structured in a way that's far stranger and far more beautiful than you imagined. And here's the thing about how we discovered this: the historical accident that gave us the wrong name. We figured out the speed of light way before we understood what it meant. Ola Romer in 1676, watching Jupiter's moons disappear behind the planet and noticing they were early when Earth was closer to Jupiter, and late when Earth was farther away. He wasn't measuring light for its own sake. He was trying to predict eclipses, and the predictions kept being wrong by 16 minutes depending on Earth's orbital position. And instead of assuming his math was bad, he thought, what if light takes time to travel? And calculated the speed based on the timing differences. First human to realize light wasn't instantaneous, and he did it by accident while studying astronomy. Then Maxwell in the 1860s working out his equations of electromagnetism, and discovering that electromagnetic waves should travel at a specific speed, determined by two fundamental constants: the permittivity and permeability of free space. And when he calculated that speed, it matched the measured speed of light exactly, which meant light was an electromagnetic wave, which was huge, that unified optics and electromagnetism into one theory. But still nobody understood what that speed really meant. They thought it was just the speed that this particular type of wave happened to travel. Then Einstein came along in 1905 and realized something that seems obvious in hindsight, but was revolutionary at the time. If light always travels at the same speed regardless of how fast you're moving, which is what experiments kept showing, then space and time can't be absolute. They have to be relative. They have to flex and bend to keep that speed constant. And that meant the speed of light wasn't just the speed of electromagnetic waves. It was a fundamental property of space-time itself. It was the conversion factor between space and time, the maximum rate of causality. And we just happened to discover it by measuring light because light was easy to measure and happened to travel at that speed. We could have discovered it through gravity. If we'd detected gravitational waves first, we could have discovered it through particle physics. If we'd built accelerators before we measured light, we could have worked it out mathematically from first principles, but we found it through light, so that's what we named it. And now we're stuck with a name that makes everyone think it's about light, when it's really about the structure of reality. And the fact that we can understand it, that we can measure it, that we can test it, that we can use it to build technology, that's extraordinary. That's what Feynman loved about physics. Not that it gives us comfortable answers, but that it shows us how reality actually works, even when reality is nothing like what we expected, even when the truth is weirder than fiction, even when understanding it requires throwing away ideas we thought were obviously true, like absolute time and absolute space. The speed of light isn't a speed limit. It's a window into the architecture of existence. And the big misconception isn't that we don't know how fast it is. It's that we don't know what it is. It's not about light. It never was. It's about causality, about information, about how space and time relate to each other, about the fundamental structure of everything. And light just happens to travel at that speed, because light has no mass, but the speed itself would be there, even if light didn't exist. It's a feature of space-time, not a feature of photons. And once you understand that, once you really get it, everything changes. Every question you ask about reality shifts, because you're not asking about speeds anymore. You're asking about geometry, about structure, about why the universe is built this way and not some other way. And that's the question that actually matters. That's the question Feynman wanted you to ask, not, why can't we go faster than light? But what does it mean? That space-time has this structure, and that question opens doors. That question takes you places. That question is where real physics lives.